Okay, hello and welcome. In this video I will try to show you how to create a simple Wwise project with usage of ZYLIA 6DoF HOA renderer and integrate it into the Unreal Engine 4. Okay, so we can launch the Wwise. And this is the main window. We are currently in the Schematic Layout. I think this layout is the best to show how the 6DoF plugin is working. For the purpose of this video I prepare a sample 6DoF recordings. So this is the schematic of this recording. So as you can see we have 3 instruments and 9 ZM1s, and the distance between the ZM1s is 1.5 meter. Okay, so to insert the recorded HOA files into the Wwise, we can just select all 9 microphones and basically drag and drop them into the actor mixer hierarchy to the default work unit. Here we don't have to change anything, we can just click import. After the import is finished, the next step is to create new audio bus on which we'll insert our 6DoF plugin. We'll call it Ambisonics, and if I extend the master of the bus, you can see that all the microphones are by default childs of the master of the bus. If I double click on this Ambisonic bus, we'll see the property editor. The first step is that we need to change the channel configuration to third order Ambisonics. So in channel configuration, just select third order. And we can now insert our plugin. So the ZYLIA 6 degrees of freedom HOA renderer is a mixer plugin. So we can insert in as mixer plugin. So click on those arrows and select 6DoF HOA renderer. And for example, this is the example configuration of this project, which I created before. But we can create a new one, basically. I'll call it default. Okay, so this is the window of our plugin, and we have the default parameters value here. And also, by default, the number of arrays is 9, which is actually okay for our purpose. And the next step is to change the parent bus of those microphones to Ambisonics. We have 2 ways to do that. The first way is to just double click on this microphone, go to general settings, just override the master bus. And we can change it to Ambisonics, but the more comfortable way of doing that is just select all microphones in the Project Explorer, right click on Show in Multi-Editor, and we can select Output Bus here. So set Output Bus, browse Ambisonics, okay. But since we are here, we can take a look at some other parameters that you can change here. So for example, we have the source settings, the conversion settings. By default, the Wwise is using PCM, which then can take a lot of place on disk or in RAM. So for example, if we have harmonic recordings, we change it to some other conversion, and to be specific, we used the Wwise Quality High, which was enough for the Philharmonic, because in Philharmonic recordings we had something like 30 arrays, and it was basically impossible to fit it in some other, some in RAM or read it from disk directly. So we needed to decrease the disk space. At the end we published the 2 versions, but Oculus Quest we're using the same settings as I set up here. Okay, but we also have the stream settings. The stream is basically that we are telling Wwise that he can read those files directly from disk and not load them into RAM when the scene and basically the sounds are loaded. And this will basically free up the memory of the computer, yeah, during the playback. I think for the 6DoF this settings should be default. We should also select zero latency, so there will be no delay between playing the sound and calling the event in game. This is also quite crucial for the correct 6DoF playback, because we need to play all those sounds at the same time. Yeah, we cannot afford that this microphone will play first before this. Yeah. Okay, you can see the project. And yeah, the next step is to create the event, yeah, because Wwise is operating on events. So if I go to event viewer, right click, new event, play, and I will just drag and drop every sound from the default work unit into here. And now basically we are ready to play the sound. Okay, but we also need to set up microphone's positions. We can do it by double click on microphone 1 and basically set up the array's position in the 3D space. Yeah? I will do it by this diagram. So as I said, the distance between the microphones are 1.5 meters, and I will assume that microphone number 5 is in the position 0, 0, 0. We don't care about the Z-axis because all the microphones are on the same height, so it can be 0. Yeah? Okay, so I will set it up. Okay, after we set up all the microphone position, you can check up the playback. So we'll just open the plugin window and I'll try to change some position and rotation. Okay, so as you can hear, the plugin is now working. Okay, but if you want to make an integration with Unreal Engine 4, we also need to set up something called real-time parameter controls, or RTPC, and create corresponding game parameters. Yeah, so basically those are objects that we can change in real time in the game. Yeah. Basically, for example, if we set up the listener position X and we create the corresponding game parameter, for example, listener X, and we set up it correctly, so we need to set up range. Yeah, for example, in plugin we have the maximum values of -30 and 30, so I will set this up in that way. And the default value is going to be 0. Yeah. And if we change something in Unreal with the listener X, it will change this, basically the slider, yeah, and this in the results will change the value of our plugin parameters, yeah, like in here. But we can also set up some curves, but we want it to be linear, yeah. So I want, if I set up the listener position in game to -30, I want to be -30 in our plugin, yeah. So we can just set up right here, yeah. And we can do this for every parameter, including rotation. Okay, I set up every parameter that I wanted, so listener positions and listener rotations, yeah. The only difference that the rotations are from -180 to 180. Okay, in terms of Wwise, I think it's all for now. So we can go to the Unreal for now. So just open in Unreal in Wwise launcher. Okay, the Unreal is loaded. Before I start recording, I create example level, which we are basically there is nothing except the floor and the player. Yeah, this example the first character, so we have some capability of moving and shooting. Okay, so now's the right time to set up some basic setup in the Unreal preferences, the project settings, and we'll go down to the Wwise, and we want to use something called event-based packaging. So basically this is a simplified workflow of Wwise in Unreal, so we don't have to generate sound banks and that kind of stuff. So we'll just select this, we'll select yes, we can delete the init bank. Okay, and now we'll restart the Unreal editor. Okay, after restart we can set up some other stuff that in my opinion are quite useful. So in the Wwise user settings we can select enable automatic asset synchronization, so in case of any changes in the audio files, we don't have to basically load everything. Yeah. Okay, I also select auto connect to Wwise API, so the synchronization between Wwise and Unreal is going to be more automatic. Yeah? And I think that's it in terms of Unreal and Wwise settings. Sample rate is okay. Integration settings okay. The Wwise project path is okay. So I think we can go to the more advanced stuff. Okay, so our goal for now is to play the event on our example level and make the player movement to influence on the sound in our plugin. Yeah. Okay, so I will try to create some blueprint script that will send RTPC values based on the camera positions and rotation. Okay, so we'll just go to edit first person blueprint, and it will open the blueprint editor. Yeah, so we have some stuff that actually we are not concerned by it. Yeah. So what we want to the very beginning of the playback to play the event. Yeah. So we are here have event begin play, which is played automatically after the game is played, basically after this blueprint is created. Yeah. Okay, to demonstrate that I can create breakpoint on this branch and click play, and as you can see this is the first event that we are encountered here. So we want to insert our event to play between those objects. So yeah, I can do that, and we'll call it post event Wwise, and our event is gonna be play, yeah, because we played that kind of event. Okay, we need also to set up actor this event. So basically on the object on which this object will play, so we'll get the reference to self because this is our player, so this is our listener. Yeah, we'll play, and I can hear something, so that's okay. It's good also to build force to click build, click force asset synchronization generates some data, to make sure that everything is okay. Okay, so the next step is to send the rotation and the position of the listener, and we want to do it for now every frame. Of course, it can be optimized by sending it only on change. So if user is standing doing absolutely nothing, we don't need to send this, but to simplify this, we will do this every frame. Okay, we can do it by add new event. It's called event tick. So this will be performing every frame. So we need to set up RTPC value. So for the first one is gonna be listener I. Okay, we can get the actor location, and we want to get the X value. So I can just right click here and split this pin, and do it for every parameter, so Y and Z. I will connect this so it will be sending first the location Y, location X, Y, and Z. We are not operating in meters here, so we need to divide everything by 100. So every value that we get here, we need to divide by 100. And the results can be finally sent to RTCP to Wwise. So the sound is changing, as you can see. Rotation is not relevant right now, but I think we'll see what's going on in Wwise. So I will open the game connectivity here. So this is visible. I will click connect, and now we have the view what's happening in the Unreal editor. So I will leave it as it is. I think I will play this. So we can see everything is playing correctly. We can also hear in the game object profiler the positions of the listeners. So as you can see right now, we have our listener X on -2 and the listener Y on 0.5. But actually we don't need to send all those positions. Okay, we don't need to send the Z position, of course, as I mentioned before. So we have our blueprints editor on this, basically. I will send it to 0, as you can see. Okay, so the next step is doing the same stuff, but with rotation. So again, send RTCP value, draw, pitch, and roll. Actually, we don't need roll right now because we are using mouse and keyboard, so it's quite hard to send the roll, so we'll send just 0. Okay, we can get the actor rotation. Again, we can split the pin and send the values. We'll get the first person camera here, and we'll get rotation, something like this, get work, rotation, split pin, and get pitch. Of course, it's all depending on if we are doing a VR game or for the mouse and keyboard game. Yeah, so it's all depending on the implementation. This is usually enough, yeah, in my experience. So okay, we'll see if it's going to work in Wwise. Change the rotation and the pitch is 14. Now it's fine. Okay. So now we have full 6 of sound in Unreal. So everything is working, and I think that's it. Yeah? The next steps are just depending on the developer and what we want to achieve.